All right, then let us try to solve these questions. Okay, so now we're gonna start with question number 11. Okay, now question number 11, 11.1, it says events A and B are independent. Probability of A is equals to 0,4 and probability of B is equals to 0,25. Now immediately when they say that the events are independent, we apply this rule. For independent events, probability of A and B is always equals to the product of probability of A and probability of B all the times. Okay, for independent events this is true, but for events that are not independent, it is not true. Now for a fact that these events are true, we know that there is an intersection between these two events, which is event A and B. Now 11.1.1, it says represent the given information on a Venn diagram. Indicate on the Venn diagram the probabilities associated with each region. Okay, now like I said, there are two events that we are most definitely talking about. So before we draw the Venn diagram, let us talk about event A. Event A, it has probability of what? Event A, it has probability of 0,40, and event B, it has probability of what? Probability of 0,25. And therefore, what is probability of A and B in this case? It will be 0,4 times 0,25. That means probability of A and B in this case, 0,4 times 0,25 is equals to how much? Is equals to 0,1. Okay, so if we have to draw a Venn diagram to answer question number 11.1, we're gonna draw a Venn diagram with two events that has an intersection, since well there is probability of A and B, and therefore this is sample space S. And then here maybe we have event A, and that side we most definitely going to have event B. So here it's event A, and then here we have event B, and therefore what is the intersection between the two events? It's gonna be 0,1 probability, because and B, it means an intersection. And therefore what is the probability of A? Is 0,4, but we're not gonna write 0,4 here. We are going to eliminate the intersection. We're going to say 0,4 minus 0,1. It is most definitely going to give us 0,3. And then the probability of B, we're going to say 0,25 minus 0,1. It is most definitely going to be 0, how much? 0,15. Okay, now guys, each and every time when you are asked to draw a Venn diagram in examination, make sure that when you add the probabilities of these events, they give you 1. Now let us try to add them and check if whether they give us 1 or not. We're gonna say 0,3 plus 0,1 plus 0,15. How much do we get? We get 0,55. Meaning the probabilities of these events, including the intersection, they do not give us 1. So because we have 0,55, meaning there is a missing probability. What is missing probability? Missing probability is 0,45, meaning 0,45, it will be out of these events, meaning it will be in a sample space, so that at least all of these probabilities, when you add them, they give you 1, which are complementary to one another. Okay, and therefore that's how we solve 11.1.1. Now we move to 11.1.2. 11.1.2, it says determine the probability of A or not B. Okay, so 11.1.2, it says determine the probability of A or not B. We can just represent it with prime. Okay, so if we want to determine this probability, we want the probability of A or not B in this case. Now we're gonna use that rule, okay, which says probability of A or not B is equals to probability of A plus probability of not B, subtract the probability of A and not B. Okay, we're gonna use this rule. Come on, Soma. Okay, this is why we have an intersection. Now to determine this, what is probability of A? In this case, probability of A, it will be 0.4, and therefore what will be probability of not B? Anything that says not B, meaning intersection, it says B. 0.15, it is also says B, meaning 0.3 and 0.45, they say not B, meaning we are going to add them. Okay, we are going to add 0.45 to 0.3, and therefore we get how much? We get 0.75 plus 0.75, and therefore what is probability of A and not B? Listen, probability of A and not B. So now probability, meaning we want an intersection between A and not B. Okay, meaning this, it simply refers to what? It simply refers to it simply refers to B only, because probability of A is how much? Probability of A is 0.4 and not B, meaning we're gonna have to eliminate this intersection, meaning it's A only, meaning it's going to be 0.3. And therefore when we punch this on our calculator, we're going to say 0.4 plus 0.75 plus subtract 0.3, and therefore we get 0.85. Okay, we get probability of A or not B to be 0.85. This is how we simply solve probability type of questions. Okay, and therefore that's it for 11.1.2. Now we move to the following question. Okay, now we move to 11.2. 11.2, it says to us, Motors Incorporated manufacture cars with 5 different body styles, 4 different interior colors, and 6 different exterior colors as indicated in the table below. Now here we have a Motor Incorporated manufacture cars. Okay, meaning in this company they manufacture cars, but these cars, the way they manufacture them based on the body styles, on the interior colors, as well as on the exterior colors. So now if they have many different cars, it's because they chose them out of these different categories. Okay, for body styles, there are 5 of them which are different from one another, as well as the colors, interior and exterior, we have numbers, which is 4 and 6. Now the interior color of the car must not be the same as the exterior color. This is very important. The interior color of the car must not be the same as the exterior color. Motors Incorporated wants to display one of each possible variations of its car in their showroom. The showroom has a floor space of 500 meters squared, and each car requires a floor of 5 meters squared. Is this display possible? Justify your answer with the necessary calculations. Now let's have a look at this question. Okay, basically this is what is happening. The company has a showroom, right? A company has a showroom. So the area of this showroom is 500 meters squared, as they say. And therefore this showroom, it's supposed to be filled with different colors that a company manufactures. So within this showroom, which has an area of 500 meters squared, there must be car placed next on each other, whereby each car, it will only occupy an area of 5 meters squared and so forth. Okay, meaning we want to determine number of cars that will be able to occupy this room. Meaning this company, it manufactures cars, right? It manufactures number of different cars. Now this number of different cars, we're supposed to multiply them. We're supposed to multiply that number with area, which is 5 for each car. And therefore if we get area maybe which is exactly 500 meters squared, now we will know that all of these cars will fit in this showroom. Or maybe if we get, let's say we have, let me make an example. Let's say this company, it manufactures maybe 200 cars. Now 200 cars supposed to fill this area. Remember, in this showroom area, each and every car, it occupies an area of 5 meters squared. Now what is the area that will be covered by cars that are 200? If one car occupies an area of 5 meters, we're just going to say most definitely 200 multiplied by 5, we get 1000 meters squared, meaning 200 cars needs 1000 meters squared area, meaning 200 cars wouldn't be able to fit in this showroom. But if, let's say for example, you have 50 cars, and then each car, it occupies an area of 5 meter squared, we're going to say most definitely 50 multiplied by 5, it is going to give us 250 meters squared. So now if we have 50 cars, these 50 cars will most definitely fit in this area, which is 500 meters squared, because there are 50 of them, and 50 cars can only occupy 250 meters squared area, meaning these 50 cars will be able to fit in this. So first thing that we need to do is to determine number of cars this company manufactures. Okay, but now how are we going to calculate that? How are we going to determine number of cars a company manufactures? We use these categories to determine number of cars. Okay, so now what are we going to do? Now listen, this is very simple. Look, for 11.2, now we have 3 categories, right? And then they said to us the interior color of the car must not be the same as the exterior color. Meaning for body styles, I don't care. For body styles, look, for body styles, I don't care which body style did I choose, but I care about the colors, because the interior must not supposed to be the same as exterior color. Now this is what I'm going to do. Interior colors, there are 4 of them. Okay, we have blue, we have gray, we have black, we have red, right? There are 4 of them interior colors, and these 4 interior colors, remember, they are not supposed to be the same with exterior colors. Now if, let's say, for body styles, for body styles, I will be choosing out of how many body styles for first category. For if maybe I choose my color to be blue, I will be choosing out of 5 body styles, right? Multiply by, and this third category is for interior color, and this third category, it's for interior colors. Now if I decide to place a blue color, meaning it's going to be only one blue color, and therefore remember, the blue color, if it appears on exterior colors, I must not repeat the blue color. So how many number of exterior colors do I have? I have 6, right? But for a fact that here I will be having a blue color for interior, that means I'm going to eliminate this blue, and therefore I'm going to left with 5 colors, meaning on this category, which is that category, I will just write 5. Now for gray color, again, for gray color, if I choose to place a gray color on this position, and therefore the body styles, I will be choosing body style out of how many body styles? I will be choosing out of 5 body styles, and therefore at this position, which is category for exterior colors, I will be choosing out of how many colors? I will be choosing out of 6. Why? Because gray, it is only for interior colors, but exterior colors, we do not have a color gray there. So that means I will be most definitely choosing out of how many colors? 6 colors. I'm just going to write 6 over here. So with these things, I don't have enough space here. I'll be choosing out of 6. Okay, and therefore if I choose my interior color to be black, I'll be choosing out of 1 black. Most definitely meaning black color is going to be fixed in that position, and therefore the body styles will be 5 of them, and therefore how many colors will I choose from for exterior colors? If maybe I place black here, now I have Do I have black on this side? No, I do not have black. That means I will still be choosing out of 6 different exterior colors. And therefore, for the last one, if I place red over here, and therefore for body types, remember I have 5 body styles. I'm going to just choose out of 5 body styles. And therefore for exterior colors, remember I placed red on this position, right? So do I have red on exterior side? Yes, I do have red on exterior side. And for exterior colors, I must not include red, meaning I'm gonna have to eliminate red. And therefore I left with how many colors? Again, once more, I left with 5 colors. So in order for me to paint my car with exterior color in this category, because I have red already, I'm going to eliminate red. I'll be choosing out of 5 numbers. Okay, now this is what I'm going to do. I'm going to take the products of these choices. Okay, here, how many cars would I be able to manufacture? I have 5 multiplied by 1 multiplied by 5, which is how much? Which is 25. And then I have 5 multiplied by 1 multiplied by 6, which is how much? Which is 30. And then I have 5 multiplied by 1 multiplied by 6, which is how much? Which is also 30. 5 multiplied by 1 multiplied by 5, which is how much? Which is most definitely 25. And if I add the totals of these products, they give me 110. Okay, so that means in this company 110 cars will be manufactured. So remember, if I have 110 cars, each car, it occupies an area of 5 meters squared. Therefore, what will be the area for 110 cars? So you're just going to say 110 multiplied by 5, you get 550 meters squared, meaning 110 cars will be able to occupy area of 550 meters squared. But remember, they said to us the showroom has a floor space of 500 meters squared, and each car requires a floor of space 5 meters squared, meaning the showroom, it has space for 550 meters squared, but the cars that we manufactured, they require an area of 550, and then we have 500. So is this display possible? No. Display is not possible. Why? Because 550 meters squared is most definitely greater than 500 meters squared. Okay, that's just how we solve this question.